We have also a second session where we have presentations that needs urgently to be held. So I would like to continue now with the second session, the presentation of different interesting research projects that are funded by the European Commission. And the first one will be held by Sophocles Ephremidis. So, and he will present the SIRENE project. So he's a project manager at Margioli, and the project manager of the project SIRENE, has participated in many R&D projects on European and national level, and also on several industrial projects. And he will present how SIRENE will address the pressing need for methodologies, techniques, and tools for efficient evaluation of infrastructures for the provision of supply chain services. So please, also for this, could you present your project?
Okay, thank you, Martin, for this introduction. Good afternoon to everyone. I guess I can share my screen. Let me try to put it in presentation mode as well. Okay, so good afternoon again to everyone, and thank you for this invitation. My talk will be on certifying the security of supply chain services and the approach taken by the European project SIRENE. Just a few words about the project. It has started on October 2000. Its duration is 36 months, and it is due to conclude by September 2023. It is a research and innovation action, and the topic was on building blocks for resilience in evolving ICT systems. So 14 partners from 10 different European countries formed the consortium of the project. We have a good blend of industrial partners, research partners, university partners, and a number of SMEs with complementary expertise on technical, but as well as legal and ethical background and expertise that they share with the project. The project focuses on supply chain services. It should not be understated the importance of those services, as they are enablers of global trade, global economy, and as we have experienced lately, any disruptions to them may have a severe impact. What has been identified is that there is no structured or standardized and trusted way to forecast, prevent, and manage interrelated and propagated cybersecurity vulnerability and threats throughout the operation of such services. And as such, SIRENE comes to fill the gap of the formal and structured approaches to certifying the security of those services. As such, the certification will certainly promote trust and confidence to the European consumers and also providers, suppliers, and also paves the way for a competitive and trustworthy digital single market. So the project takes a focus on the supply chain services, and it's certainly contrasted with other initiatives and projects that they focus on certification of IoT, of home environments, of software components, and so on. So SIRENE tries to enhance the security, resilience, privacy, accountability, and trustworthiness of supply chain services through two main outputs: a certification scheme, a set of rules and technical requirements and standards for the certification of those services, and also a risk and conformity assessment methodology to assess the security and resilience of services, of the underlying IT infrastructures, and also of individual assets of those infrastructure. So the value proposition, SIRENE provides services, building blocks, and tools for an enhanced risk assessment process that serves also as a conformity assessment process. So the innovative proposition of the project is this duality of the risk assessment on one hand and conformity assessment process on the other hand, to evaluate the security and resilience of supply chain services and its security objectives following NIST 2.0 directives. So the RCA methodology is of dual use. On one hand, it can be used by individuals and self-assessors, For example, supply chain providers, business partners, supply chain stakeholders, and so on, to manage risks and generate supply chain service protection profiles. This part of the methodology, this aspect of the methodology, of course, is supported by a set of tools and services. The other use of the methodology is intended to be used by third-party risk assessors and conformity assessors, basically oriented towards auditors, certification bodies, and so on. The assurance levels that are foreseen by the methodology, of course, depend upon the criticality of the sector in which the supply chain services operate. And the methodology provides support for either a basic assurance level, which can be performed by self-assessment of supply chain services, or for the substantial and high levels are those that can be applied by auditors and certification bodies. So the proposed supply chain service certification scheme by the project, of course, follows international standards, and in particular, it is an extension of the ENISA EUCC. Supply chain services are seen as targets of evaluation, and they are treated at three abstraction layers. On the assets layer, that relates to components, devices, IoT devices maybe, the infrastructures on top of which are interdependent, interconnected, heterogeneous, may span multiple administrative domains, and also the supply chain business processes. Along with these three abstraction layers, there are three viewpoints under which we see and we assess supply chain services: the sectorial, the technical, and the business. In this whole journey that starts with the target of evaluations, which are our supply chain services, and it goes to risk assessment, to risk identification, analysis of risks, evaluation of risks, treatment of risks. Of course, we take into account and we use as background for the project goal a number of international standards. Sectorial cybersecurity assessment by ENISA, of course, we are based on the Cybersecurity Act, cybersecurity certification, the ETSI standards, CBSS, and so on. And in addition to this, of course, we take as basis for our work the ISO 28K standards, 27K standards, the common criteria, ISO 15408, and so on. And as we start modeling our supply chains, exactly because the first thing into this journey is to model the supply chain services so that we be able to reason about this, we try also to model and position the project within the context of legislation standards which are part of our environment. So the red parts of this self-model, if I may use this term, is to show the parts where Cyrene contributes. Our starting point is the European Cybersecurity Certification Scheme by ENISA, which we extended to a scheme that pertains to supply chain services. As part of this scheme, we have defined the conformity assessment process for supply chain services, of course, which is supported by a number of tools, and we treat supply chains as the targets of evaluation. Protection profiles for supply chain services and security targets for supply chain services have been identified as a result of requirements gathering that has been completed by the project, either through project partners or through questionnaires that have been distributed to wider audiences, and also requirements that come from legal requirements have also been taken into account. So just a few picks on the outcomes of the project is the methodology, which is shown here in a high level. So the methodology comprises a number of steps. First off, to set the scope for the supply chain services, risk assessment, conformity assessment. Then to analyze the supply chain service, to set the scope, objectives, requirements, business partners, model the supply chain services, then perform threat analysis, then vulnerability and impact assessment, risk assessment, risk compliance to security assurance certification scheme, and then risk mitigation. Along this whole methodology, a number of new formulas have been developed that allow us to assess the vulnerability of assets and infrastructure that participate into supply chain services, and also the impact that risks may pose to this. Models have been completed, and they allow us to reason about supply chain services, the fundamental concepts and interrelationship between those concepts have been modeled, and the resulting models are used in order to provide the basis for the risk assessment and conformity assessment of the supply chains. Threat analysis, of course, is an integral part of the methodology itself. It takes a number of sub-steps: the identification of threats, assessment of threats. Of course, the work is based on international initiatives, so the MITRE attack, deep and dark web mining, anomaly detection and classification algorithms that have been developed within the project. Vulnerability and impact assessment as well is based on the CVSS 3.1 with which and use of the metrics, either based temporal or environmental metrics, which are foreseen by CVSS 3.1, but of course with extensions, with new parameters that need to be taken into account when we need to assess supply chain services. So these new things and parameters extend those by CVSS, and they are taken into account for assessing the vulnerabilities of the assets and the infrastructures that support the supply chain services. Assets are modeled along with their vulnerabilities. Vulnerability graphs are modeled as well. The result is vulnerability chains that model how vulnerabilities can be exploited by potential attackers. And then, as a result of this, we get some metrics on the vulnerability exploitability estimation. So the attack path exploitability is also modeled along with the probability of attacks being performed, which are the basic mechanisms that allow us the assessment and the evaluation of the impact of attacks to the targets of evaluations, which are, in our case, supply chain services. In a nutshell, we occupy the central area of this image. So the methodology that is complete by now, the toolset which is complete, but it is under integration. The result of applying the methodology and the toolset into our target of evaluation, to our target of evaluation supply chain services, is a label, as we heard before. The project will evaluate its methodology, risk assessment and conformity assessment methodology, and the toolset into pilot supply chain services. As a result, the methodology and the toolset will be assessed and finalized as a result of those tasks. So this is a short statement on Cyrene. I thank you for your attention. My contact details are here, and you're very welcome to follow us in a number of social media feeds, which are updated regularly, right, almost on a daily basis. Thank you very much for your attention.
Thank you very much, Sophocles, for this interesting presentation. I think this project looks at that we should follow you and your social channels so to be stayed updated. So maybe this is also one way to communicate with you.
Thank you very much.
So I would like to remind you that you can raise questions using the Q&A button or the chat if you like. So don't hesitate to use these tools so that we can also have more insightful discussions for the interests of you, the audience. The next presentation we will have now is about the Concordia project, and Argyro Chatsopoulou will help this presentation. She's a member of TÜV Trust IT, is currently leading the certifications and standardization task of the Concordia project, and is an experienced consultant, trainer, lead auditor, and scheme developer, and active in various standardization bodies. She contributes to the Concordia project that is operating a pilot for cybersecurity competence network to develop and implement a cybersecurity research and innovation roadmap. And in her presentation, she will show the link between standardization and certification by taking as example existing development and challenges in the domain of IoT devices. So, Argyro, this is your stage.
Thank you very much. Let me share my presentation first, and hopefully you can see me, and now you can see the screen.
We can see you and we can see your presentation. Thank you.
Okay, great. So thank you very much, Mark, for the introduction. I think you covered the information regarding the project. I'm going to just briefly say that Concordia is a large project. It started in 2019 with the aim to pilot cybersecurity competence network, and the outcomes of these pilots, which are four, are supposed to provide information regarding the creation, the development of a common cybersecurity research and innovation roadmap for Europe. And exactly this roadmap is something that we're going to discuss today after we see the connection between certification and standardization in this particular subject. So I will reiterate a definition that was mentioned earlier today in the previous presentation, that certification is a third-party attestation regarding to either products or processes or systems or people. And when we say attestation, we mean that it's a statement that is based on a decision that has been derived from a review. And this review had the purpose to check whether specific requirements and specific obligations have been fulfilled. So during a full certification to exist and certificates to be issued, there's another step behind where we do this, what we call audits or checks, where we try to find evidence that specific requirements have been met. So this is why the definition has words like demonstration and fulfillment of requirements. This certification definition that is very generic and comes from our certification standards issued by ISO is also present within the CSA. So within the field of product, we have the CSA, and it also was mentioned before that we have to test products, and this testing has to be made by approved and appropriate methods. And through these test methods, we have to show that the cybersecurity requirements for specific products are fulfilled, and that they achieve a specific level of assurance, and that the cybersecurity risk of a specific project is of an equivalent value. So I know this is not something new for you, but I'm just setting the scene a little bit and connected to the previous presentations. So How does certification connect to standardization? We already saw that a little bit today because we talked about standards, and standards come into two specific areas within this ecosystem. The one relates to the cybersecurity requirements that need to be filled in, that need to be fulfilled. And we saw today, we have seen also in a relevant documented publication from ENISA, that we have many different standards that talk about and that present requirements. And it's very important that we know exactly which are the standards that we need to follow, which are the standards that need to be fulfilled for each specific case, and to make sure, as was mentioned also in the previous presentation, that requirements that are set are interoperable so that we can have an effective chain in fulfillment. And that the relevant certifications that are extracted from this, based on these standards, are of value and fulfill the objectives for which they have been created. Another area where standards are needed, and this is also related not only to the framework that was presented for consumer products in the beginning of this webinar, but also this conference, but also by just the previous presentation by the Cyber project, where they talked about the methods based on which an audit and a check can be carried out. It's not just about setting the requirements, but it's also setting the way that these requirements are going to be tested. So we need to know exactly what kind of tests we are creating, what is the mechanism to do so, what is an appropriate methodology, and how the report can be created, and how to make sure that different organizations, different certification bodies, as mentioned before, have the same and comparable results, and then the end result, which is the certificate, is something that is comparable for all. And it was mentioned also during the previous discussions that we have so many IoT projects that we don't have enough certification bodies and labs to do this test. So it's really, really important that we have a common understanding and common standards that would allow us to make these certification processes as comparable and as valuable as possible. So I have chosen to show you, just to showcase just two examples of approved and appropriate methods and standards. One is about consumer products that you saw also in the beginning, and the other one has to do with the security, the ISO IEC 15408, and the various parts of the standard that also relate to assessment and testing. So it's really important that types like this, standards that cover these two areas, which are not really limited. It's a huge area. If we consider the types of IoT products, it's really important that these gaps need to be filled in. So Concordia is trying to, as I said in the beginning, in the introduction, is trying to create a cybersecurity roadmap for Europe. This is a work in progress. The final version of this roadmap will be released at the end of the project, at the end of this year, actually, but already a draft version, a preliminary version of the roadmap has been issued, and there's a dedicated mini site under the Concordia website that contains all the roadmap information. One of the axes of the roadmap is, of course, certification and standardization, and the goal within this mini roadmap was to identify the challenges for each domain and propose activities in order to face these challenges. And Of course, we have identified these gaps in the short-term activities, short-term aims that need to be filled in, both from a standardization point of view and from a certification point of view. And we have set the highest priority. I do not show you everything that we have proposed because it would be a little bit difficult within these slides, but I would like to stress out that we have identified in the very beginning of the activities that need to be taken in the next few years, things that are related to the IoT domain and the standards that are needed within this domain and the certification activities that need to be implemented within this domain. As I said, there is a mini website that has been created and a document that has been created for the roadmap, and you are free to reach out to the Concordia project with the communication methods that are mentioned within and comment accordingly. I hope I'm not too late. Thank you very much, and I will be available for questions.
Yeah, thank you very much, Alguiro, for this interesting presentation about this Cyrene project. I think would also be valuable input for the standardization activities, and we will see how this will be realized. Again, we would love to hear what you think about the presentations, the topics, and the project. So don't hesitate to use the chat or the Q&A tool to raise comments and questions, and please do so if they come, when they come to your mind. And for the next presentation, we will have here Dr. Ruth Sophia from the EU-IoT project. So she's industrial IoT head at Fortis, a research institute of Bavaria in Germany. She's also invited professor and associate researchers and has co-founded research units and startups. And she will present the Cooperation and Support Action Unit EU-IoT that acts as an accelerator for the European IoT ecosystem. So, Ruth, this is your stage.
Okay, so thank you. Hello, everybody. Can you hear me?
Yes, we can hear you well.
Okay,
and we see your slide.
Thank you. So as Martin said, I'm here to represent EU-IoT. So EU-IoT is a cooperation and support action that supports the ICT 56 program, so next generation IoT. And in EU-IoT, among other things, I'm responsible for the standardization and open source activities. And today, so what I bring you is an analysis, a perspective of an analysis that we have been doing over the last year based on the research and innovation actions of the next generation IoT program, with a perspective in terms of which areas the areas are being focused and how is how is cybersecurity and trustworthiness being addressed. So in this slide you have to give first a perspective on the positioning of EU-IoT. So as a CSA, as I explained, we support projects in ICT 56. So there are 6 flagship projects in this context, which you see here. But we also interact with other CSAs such as OpenDEI, and we cooperate with different SDOs, different pre-standardization entities, consortia, and this is done so in terms of EU-IoT, we are focused on different vertical domains. So in terms of areas, of broad areas that we address, so I explained that here I represent the work package that leads to the standardization, which is a EU-IoT catalyst. But then, of course, as a CSA, we also do other actions. So above all, engagement and so expansion of the IoT community. But also in the CSA, we also have developed materials. So we develop training, we do skills surveys, and also impact assessment of the projects. And of course, in a way that is interconnected to the projects, but also to a broad database of experts in Europe. The same format. So in terms of EU-IoT, how do we cooperate? So we work directly with the RIAs. So for instance, the analysis that I bring today is based on direct interviews, surveys, workshops that we establish directly with each of the projects. We also establish workshops and, for instance, other types of collaborative initiatives, such as white papers with the different STOs and pre-standardization and consortia entities. So consortia are in standardization. And we cooperate, of course, there's participation of EU-IoT across different task forces that are related with the Internet of Things global scope in Europe. So technically, where do we work in IoT? So what are the knowledge areas or the scope areas that we focus upon? So EU-IoT provides an end-to-end or addresses an end-to-end perspective of IoT, as you have here. So we have created, or we focus on the scope areas that you see here. So interfaces, far edge, near edge, infrastructure, and data spaces. And then this analysis is addressed in, so not just from a technological perspective, but also from a market and business perspective, standards and policies and skills. So I'm going now to give you a perspective on the analysis that we have been doing on the RIA. So we analyze different aspects. For instance, what are the contributions that the projects are providing to different, so first of all, to our scope areas, so data spaces, infrastructure, near edge, far edge, and interfaces, but also in terms of vertical markets and use cases that are being developed, what is the current focus. And so this is a summary that you have here. So there's a deliverable with this information if you want to check. Basically here on the left-hand side, what you see is that most of the projects are focusing on data spaces and infrastructure, but in terms of use cases, there are also use cases that address already the extension and operation of the Internet of Things until the terminals, the end user device, the so-called far edge. And therefore, there is a good balance in terms of contributions to these different scope areas. Also, in terms of the clusters, so let's say and SDG objectives, where are the projects focusing? So we have also, of course, most of the focus is on ICT because this is so an ICT program, but the projects are also focusing on areas such as energy, mobility, or climate, and also so agriculture, environment, and health. So there is also a good balance in terms of use cases. Of course, in terms of IoT, the focus in terms of, for instance, civil security for society is not here really patent because of the nature of the program. Then in terms of vertical markets, the use cases are also covering widely the different use cases, the different vertical markets that we have in Europe, with more focus on manufacturing, logistics, and transportation. So we have also done an analysis in terms of the technological impact of the projects, and I think this is possibly the most important part. So what we wanted to understand was what are, let's say, the key topics that are being addressed in each of these projects. And then we created recommendations, so research recommendations towards the integration of the outcome into STOs. And so I'm just going to give a few examples here. So for instance, this categorization was done in terms of the different scope areas of EU-IoT. For instance, for the far edge, you see here some of the topics that are being addressed, distributed AI across far edge and interfaces. But for instance, the projects address the need of the use of open hardware, acceleration, for instance, this is one of the topics that is mentioned in multiple projects, neuromorphic computing, brownfield integration. And derived of the actions that the projects are doing, we created a set of recommendations towards future use. For instance, that some of the outcome that is being addressed in terms of federated learning could also be injected or discussed with specific IEEE groups, in particular the machine learning related groups. The same way, so we analyze these for the different EU-IoT scope areas, and in terms of, so again, you see here the topics, federated AI and decentralized AI, also with the preponderant presence across the different scope areas. But so in terms of trust and trustworthiness, what we see is that the projects are mostly focusing, of course, on the data part. And I will give you also this perspective in one or two slides. So in other words, this means that the cybersecurity aspects and the trustworthiness aspects are actually being quite focused on data spaces, but not addressed fully from an end-to-end perspective in IoT. So we've also developed an analysis of edge, so knowledge areas. So what I showed you on the prior slide are subtopics that each project develops. But from an European perspective, which areas are we speaking about? And there are, of course, different definition of knowledge areas. So EU-IoT, of course, as a CSA has a specific one. But what we decided to do was to collect the different knowledge areas based on subtopics across relevant European sources. For instance, so the Artemis, so the new industry association, or also from strategic documents coming from the European Commission. And we ended up creating these knowledge areas, or at least categorizing the subtopics that we have based on these knowledge areas. And what we see first, so this does not relate to the project, it is more broad, is that what we did next was a mapping of these main knowledge areas into different standardization groups. So here on this table, you see SDOs, pre-standardization, consortia entities. And for instance, if we look into cybersecurity, we can see that again, at least the mapping that we have so far points out that potential input can be provided by the projects to ISO, but we are still missing other relevant consortia in this context. So of course, this mapping that we did reflects only work from 1 year, and the RIAs that I'm speaking about are also starting their work because most of them started by the end of 2020. But this also shows that there is a good possibility, for instance, if we go to infrastructure, there is already a broad range of entities where the projects can demonstrate and discuss their results. But in cybersecurity, this is still possibly one of the issues. So we have also analyzed, so this is my last slide, we have also analyzed in terms of these knowledge areas and in terms of the EU-IoT scope areas that you see here, where exactly are the contributions falling? And so in dark blue, what you have are the contributions done so far. In red are areas, so knowledge areas that have so far no contributions. And in gray, you have areas which are not related to the specific focus of the IoT next generation in ICT 56. So this means that, for instance, we have here some new fields, of course, like quantum, very early, so natural that we still don't have contributions. But there are other fields such as quality of software certification, where the input is still really, really low. And if we go to, sorry for it's my mouse that moves. If we go to cybersecurity as a whole, we can see, so what I was transmitting before, that in fact the current contributions fall into the data spaces, while we are developing in terms of Internet of Things, new concepts that go until the far edge, so that have new interfaces, new types of technologies, augmented reality, extended reality technologies. But the trustworthiness, privacy preservation, cybersecurity aspects are not yet really addressed. So, and this is, in our opinion, one of the gaps, of the main gaps that we found. And of course, we are continuing our work, so we expect to provide some recommendations also in this context. Thank you. So I pass to Martin.
Thanks, Zoe. Thanks, Ruth, for this interesting presentation and the useful insights. If there are questions from the audience, please raise them. Use the Q&A button at the top, at the bottom of the Zoom tool, or put them directly in the chat if you wish. The next presentation we will have will be held by Enrique Santos from the Fishy project. So he's associate professor at the Information Systems Department of the University of Minho in Portugal, and his research activities are integrated into the Algorithmic Research Center there. The project Fishy aims at designing, developing, and validating and demonstrating a coordinated framework for cyber resilience, provisioning to guarantee a trusted supply chain. And Enrique will present one of the dimensions of the Fishy project that will be about managing cybersecurity privacy issues between nodes within the supply chain. So the stage is yours, Enrique.
Thank you, Martin. I expect you are hear me. No problems?
Yes.
Okay, thank you. Thank you very much for the invitation. And it's my pleasure to present also here the Fishy project and how the Fishy project is approaching this problem of the certifications and the standards. Let me start with a very small presentation of the objectives of the project. Basically, Fishy project aims in the development and the design and development of a platform that integrates several other platforms for cybersecurity. But the objective here is building a trusted supply chain of information and communication technology based systems, which are very complex and above all, they are very heterogeneous. And as such, a specific objective is to develop an evidence-based security assurance and certification methodology. We, in the project, we are addressing 3 different use cases, and each of these use cases represents a different type of supply chain. One first use case is focused on efficiency, and is a farm-to-fork use case, which basically aims to develop such a platform for supporting the trust level or trust management between all the players involved in producing, from the producing of goods from the architectural to the distribution of foods into the market. Another supply chain is more focused on efficacy, is the web-based panel industry. Is much more focused on the production of and the efficacy of these production goods. And the last one, which is focused on more on responsiveness, is a development project also that aims to build autonomous vehicle network. Of course, there are some missing types of supply chain, so the project works like a proof of concept mostly. It's important to highlight what we face in this project as a supply chain. Is a very complex network of nodes using different technologies, and they are involved in the same, more or less the same cycle, from production of raw materials to the delivery to the end user. So all these players should be integrated somehow, and of course this is a very challenging aspect of the project. And all these nodes, they are relying, their function is relying on information sharing, and with this tendency to digitalization of the supply chain management, of course, this raises the cybersecurity issue here. So cybersecurity becomes very critical in this context. So the main questions we have in the beginning of the project: how to handle the heterogeneity of involved organizations, mostly not only because of the technology, but because they have different security objectives. How to align these different cybersecurity perspectives along all these players, and above all, how can we measure our partner cybersecurity while keeping our own indicators visible? And of course, all of these without jeopardizing the privacy and secrecy requirements we have. So in special, this last part has to do with metrics and has to do with measurements. And it's a very important aspect. We have some standard focus on this detail, but most of the standards we have, they don't focus on this. So I'm going to go through very quickly through the role of standards, because this has been discussed, but standard is basically something that we agree all together, promoting the interoperability of systems we are facing, and especially they are not low. This kind of the imposition, if you want to call it that way, also implies some loss of flexibility, limiting the business, of course, and it is important to define clearly at the business level who is paying the penalty of adopting this standard. And especially when we are facing small and medium-sized enterprises, this may be a very important problem. And of course, there are this dichotomy between the bad ones and the good ones. The bad ones are those that cannot afford a certification level, and the good ones are those that can do that. And just not being certified does not mean that the company is not providing a good service. It just they cannot afford the evidence. So within FISHI, we are worried with this condition. And of course, cybersecurity is special, well tailored for this kind for cybersecurity for these standards and the certification. We already have been working on all the frameworks we discussed, and I just want to highlight here the EX 62443, which is focused on industrial automation and control systems, and mostly because it introduces this maturity level, which is very important, because what we saw in the examples and from the previous studies we made, we understand that in these different nodes of the supply chain, the perception of security and the maturity level to define properly the security objectives is really very important. Of course, there are other frameworks that we follow, and from all this discussion today, from my colleagues, we have seen that the number of standards is really high. Other available frameworks are non-institutional ones, and we are also addressing some of that. It's also important to see how the certifications from ISO are being adopted, and especially because concerning the 28,000 standard with aims specifically for a supply chain, the number is very low. And if you look for countries, for instance, it's also important to see that in the UK is a country where this certification problem is really addressed by all the players, and that's why they have the number of certification in 27 and one of the highest values. And looking for the activity sectors, as we may expect, also companies working in the information technology area, they are more prone to be certified or looking for a certification. But in the industry in general, as you can see, the number of certifications and the motivation for certification is very low. It has already been discussed why it is difficult. There are an absence of culture, the lack of support from top management, lack of motivation, and the skills that are implicit in any organization are also limiting factors. How are we approaching all these problems within FISHI? As I said before, we are based our methodology on the 62443 standard, and using the PDCA-like model, as you can see in the right side of the slide. And one of the reasons is this segmented approach. The standard allows us to define zones and countries, making a segregation of technologies and production units inside the organization, and making it possible to define in a more specific way the security objectives. This is a very important aspect, along with this multi-stage risk assessment, which allows us to address different risks in different stages of the maturity level path in any organization. And of course, security assessment is fundamental. Linking metrics to measurements and to target security levels is also very important. And we found here a very important aspect is the continuous security assessment, which FISHI allows to get, because if we define metrics within the project, and we are working on that, that allows us to measure the real aspects of the certification, we may be highlighting this kind of continuous security assessment and continuous certification, which is very important, especially for small companies. And finally, the difficulties and the challenges we are facing in first place, as I said before, metric definition. What metrics should or can we use to evidence the proper effects on a given security objective? This is really very important, and possibly a new standard may rise here. And the limited capacity to define the proper target security levels, the cost of acquiring such metrics, and to extend the process that we are now at this moment. We are focused more on IT, but it is really necessary in these supply chains to focus also on the OT area. And that's it. Thank you. And I'm ready for any questions.
Thank you, Enrique, for the interesting presentation. We collect the questions right now, and we will answer them in the panel discussion. So please feel free to answer to ask the questions in the Q&A chat so that we can discuss them afterwards. Thanks, Enrique. So the next presentation will be held by Saranice Mathieu Garcia. I guess I pronounced the name wrong, but hopefully she forgives me. She will present the VIECO project, and she's a postdoctoral researcher at the Department of Information and Communications Engineering at the University of Murcia. Her main research interests are related to the security evaluation and the lifecycle management of IoT devices. She's a work package leader of the VIECO project that builds a holistic framework to understand and manage the cybersecurity risk and threats companies may be subject to, and she will present some results of the project related to the security evaluation methodology. So please, Sarah, the stage is yours.
Thank you, Martin. Well, as Martin has said, the VIECO project has a toolbox of results. We have vulnerability propagation, forecasting, mitigation, auditing, monitoring, prediction. But today I want to tell you the results of the work package 7, which is the definition of a methodology for evaluating the system cybersecurity. So I will go through the requirements that we identified to define this methodology, the overview, the methodology step by step, and what we are currently doing. So the majority of the requirements has been already discussed this morning. We need to homogenize the comparison. We need to find these common criteria to evaluate the system cybersecurity. We know we also need to deal with the cybersecurity changes through all the life cycle of the system. And we need to make this process as cost-effective and automated as possible, because we are for sure going to need a recertification process. We need to take into account the context in which the system will be operating, because it will the security condition will depend on it. We will need to consider also different security dimensions and impacts beyond cybersecurity, for example, privacy or safety. And we should also take into account this end user, because he or she is a non-expert, and a visual level will help to understand the result of the evaluation. So taking into account all these requirements, we define a methodology which is this one in the picture, based on these standards, the ISO, ETSI, and the MAD standard. And well, this is just a set of steps that should be performed to evaluate the system cybersecurity. So we have a first phase, which is the establishing the context, in which we take all the information from the state of the art, the best practices, regulation, vulnerability databases, and we create what we call tolerance profile. I will explain this later. Then we identify what is applicable to my system. We validate empirically if the risk is present or not in the system through the security testing. With the test results, we estimate the risk and we decide if this risk is acceptable or not. And we have some additional activities, for example, the creation of this visual label, the mitigation proposed to address some security issues encountered during the process, and also the continuous communication and monitoring to deal with the security changes. So let's go step by step. So in the first phase, as I have said before, we need to obtain all this information from the state of the art, the best practices, regulation, to create this basic set of what we need to evaluate. I mean, certification doesn't start from zero. We need this basic set of claims. So that was the first task of the work package, and we identified 75 generic security and privacy claims coming from 11 standards to legal framework from privacy, and 11 best practices documents. Just here, this is an example of how we define these claims. For example, this is the claim number 2, update software files should be encrypted. And we classify this claim based on stride, on the impacts. We have some requirements necessary to apply this claim. We have dependencies with other claims, on proposed tests, and also the sources of information in which we have found this claim. For example, in the ETSI standards, IETF or CECI, etc. So now that we have this basic set, we create some tolerance profiles. These tolerance profiles describes for each one of the 6 security properties that we consider in the methodology: confidentiality, integrity, availability, authorization, authentication, and non-repudiation, the tolerable risk for each one of them. So for example, for confidentiality, the tolerable risk is from 0 to 7. These tolerance profiles are intended to be specific for a specific context, for example, for health or for vehicles, for a home, because the security requirements are different in each context. So then we have to identify which requirements are applicable to or a particular system. So we go through the system high-level view to the individual tests. We have the system, which is associated with these 6 security properties that comes from STRIDE in a positive way. The security properties are associated with the components of the system, which also consider the sensitivity degree, as how, if something fails, how this affects me as a component. The components is linked with claims, the claims we defined before, that can be pure if they are directly associated with tests, or vulnerability claims if they are linked to existing vulnerabilities from the National Vulnerability Database or whatever. Okay, so now we have identified what we are going to evaluate. So the key point of the methodology is to combine the results of the risk identification with the results of the security testing. So we use the identified risk to identify and prioritize the test, and we use the test results to measure in an objective way the risk. So in the security testing, we have these different phases, the usual ones in which we have to design the test, specify the entities, the steps, the condition to pass or fail. We have to implement the test using a particular testing techniques. For example, if we are using model-based testing, we need to implement the adapter to translate the high-level model to the particular real system. We have to prepare the environment and the entities needed to execute the test, and then we execute the test. The tests are not, all the tests are not binary. I mean, not all the tests are pass or fail, because in some cases we obtain also some metrics. An example, for the denial of service attack, we can obtain the maximum number of simultaneous connection before the system crashes. That's a metric. So once we have all this test report with the results of the test, we estimate the risk. For this, we use the typical formula likelihood per impact, and we obtain the likelihood from the test report. If the test pass and this vulnerability is not present in the system, if the test failed, the vulnerability is present in the system, and if for non-binary tests, the metric that we obtain is weighted between 0 and 1. On the other hand, the impact, we obtain the impact based on 4 different dimensions: safety, privacy, and legislation, operational, and financial. This classification comes from the Hivens and EBITDA approaches. So then we go from the test to the system properties using some formulas. Okay, so now we have for each one of the 6 security properties a risk associated. So now we come back to the tolerance profiles. If the system, for example, for confidentiality, if the system obtains a 3 in confidentiality, it is in the tolerable risk interval, and we obtain the B. If the system obtains an 8 in confidentiality, this is not acceptable, so the certificate cannot be granted. So with this information, we obtain for each one of the security properties an A, B, C, or D. And this is used to create the visual label. This label is quite visual because it is for non-expert consumers. And the idea is that more area, more greener, more secure. So the vertices of this label are the profiles of the security properties. And we also consider a QR code to deal with the changes of the security of the certificate, and also to include in the future some information about the testing process. We also have this treatment phase because the process doesn't end here. I mean, we discover a lot of issues and we want to do something with this information. So for this, we use the standard manufacturer usage description is from the IETF. It is a behavioral profile, and we extended this behavioral profile to include some recommendations for the deployment of the device. For example, a recommendation on the security parameters, limitation on the connection, restrictions. So this profile can be used to configure in a secure way the system or the components, but also to monitor if the system behaves as expected. Finally, we have this continuous communication and monitoring that we currently don't address, but it is intended to deal with the security changes. I mean, due to new vulnerabilities, to update this, that may start a reevaluation process, and that should be linked to the certificate lifecycle, to revoke, to update it, whatever. Finally, well, currently we are working on how to instantiate each step of this methodology with specific techniques and tools, with tools developed within Vieco for vulnerability propagation and detection, for modeling and testing, and open source tools. Indeed, I can tell you that for security testing, we are using GraphWalker for model-based testing, a fuzzing tool developed by your partners from Gradient, and also Groot for GDPR compliance that is developed by CNR. And that's all I wanted to tell you. Thank you so much.
Yeah, thank you very much, Sarah, for this interesting presentation and what you are doing in the project and what the results will look like. Interesting. If there are questions from the audience, please ask them in the Q&A chat, and we will discuss it afterwards in the panel discussion. So the next presentation will be from about the Assured project, and it will be held by Dr. Dimitrios Papavatavianos. I'm sorry for pronouncing the name again wrong. He's a cybersecurity research associate in the Digital Security and Trusted Computing Group at UBTech, and holds a PhD on advanced AI methods for network intrusion detection systems. He will introduce the EU-funded Assured project that is introducing an innovative, formally verified runtime assurance framework for securing CPS supply chains. And he will provide an overview on the latest advancement of the project. So please, Dimitrios, the stage is yours.
Thank you. Can you hear me?
Yes, we can hear you well.
And can you see my screen also?
Yes, it works perfect.
Perfect. Thank you. So, hi everyone. I'm Dimitris Papamartzvanos. I'm a cybersecurity research associate in the Digital Security and Trust Computing Group for UBTech, and I will introduce you to the Assured project. So, our aim is to provide, to future-proof the ICT supply chains, and our mission is to actually provide these enablers in order to provide the operational assurance and verification of all these kind of distributed devices that are taking part in the supply chains of today. Our vision is through the Assured to provide a platform to and design and implement a platform that which is policy driven, and through runtime assurance framework we can act and formally verified actions to ensure the operational assurance of these chains. The project started on the 1st of September of 2021. We are currently on month 20. And there are 14 participating partners from 10 different European countries participating in this research and innovation action. So what is the motivation behind Assured and the challenges? So currently we all know that there is a need for certification mechanisms in order to ensure safety, but actually safety has a duality between security and safety. So this means that we need to ensure, of course, security, so that to a certain extent to ensure also the safety of systems. Nowadays, this is also solely focused, let's say, on rigid methodologies where we actually try to certify systems and validate systems during the design time of phase of the systems. But we need also to focus on the dynamicity of these environments and apply certification during the runtime of systems. Of course, there is also a need to ensure assured services and their operation during runtime, but at the same time, by not threatening people which interact with the devices and these kind of ecosystems. So overall, we need to combine the security and trust and the safety qualities to provide verification techniques that ensure that all these devices and environments behave in a legitimate way, to research for decentralized roots of trust and actually push the assurance verification toward the edges of the network, to certify, to provide this certification and assurance verification in an efficient manner, and enable data sharing, including also collective threat intelligence data sharing, but in a privacy-preserving manner and with proper access control. So our vision is to achieve these qualities by providing an holistic platform for the security, privacy, and operational assurance of the systems. And to achieve this, we are standing on specific technological pillars. What we try to do in Assured is to provide a middleware that will help us to provide the security and the management of the edge devices, focusing on specific hardware, software, components residing in network topologies. To do so, we focus on the research and development of remote attestation schemes, the integration of reactive runtime risk assessment methodologies, and as we said, in the context of the mixed criticality applications that pose these different security and safety requirements. Let's take a look over the project goals one by one. So the first goal, as we said before, is to enhance the operational assurance of supply chains of heterogeneous devices. In order to achieve this, we have developed a new breed of attestation schemes a variety of them actually, focusing on control flow attestation, configuration integrity verification, direct anonymous attestation when we have also privacy aspects to consider, jury-based attestation, and swarm attestation. In order to enable the attestation of systems, we also research and we develop software-based tracing mechanisms so that to provide the actual evidence that we need in order to attest systems and the actual systems. And in order to actually exploit the benefits of blockchain, we use blockchain in order to enforce attestation policies through the blockchain and be sure that all these attestation results remain accurate and have the necessary integrity. When it comes to the second project goal, we focus on the development of runtime risk assessment methodologies. So, we develop a methodology which is not solely focused, on the design phase of systems prior to their deployment, but also we extend this notion to the runtime risk assessment based on evidences. This risk assessment approach is also blended with the definition of specific security and attestation policies, which try actually to solve and consider several aspects of the systems based on constraint-based optimization methods in order to ensure both the efficiency but the security of the systems and the trustworthiness of them. This is done through the blockchain again by using also smart contracts in order to deliver this kind of policies and instruct a specific way of behavior and execution to the systems. Through the blockchain and the smart contracts, we are able actually to perform this validation and verification using a formal security manner. The third project goal is to enable data sharing and threat intelligence information sharing specifically. This is also achieved in Assured through the use of blockchains, but with the novel blending of several crypto-based operations. So we focus on the development of trusted authentication mechanisms, crypto operations specifically for trust, attribute-based encryption, searchable encryption, and in order to be aligned also with the SSI standards, our aim and our developments also include the use of blockchain wallets on devices, so that to ensure that all these interactions with the blockchain pass through a trusted entity. And actually the blockchain wallets that we are developing is also in part with a trusted component. And in our case, in Assured, we make use of the trusted platform module known as TPM. Regarding the fourth goal, we actually aim to evaluate all these attestation mechanisms in different environments, virtualized environments, and consider also diverse devices. The last but not least important goal of Assured is also to contribute to standards and to push the attestation certification and blockchain developments through by conducting the TCG, ISO, IEC, and EDGE groups for this. A short presentation over the use cases where we are trying to actually implement and apply all these developments of Assured. We are focusing on smart manufacturing, where actually the focus is to ensure the data integrity and trustworthiness, especially in cases where where we actually have to sorry for this, where we have to deal with safety critical operations with the human-robot collaboration cases. In smart cities, where we try to apply runtime risk assessments, so that to ensure that the surveillance systems run in a legitimate way, and we also apply privacy-preserving methodologies there for data sharing. Smart aerospace, which is a safety-critical use case where the aircraft components, the IoT components in the aircraft and microcontrollers needs to be attested so that to ensure operational assurance. Smart satellites focusing on critical operation like the cryptographic key distribution, which is used as an enabler for several applications. The consortium, as we said before, is comprised for 14 different partners, and we're capable of delivering everything that needs to be addressed, from the generation of ideas, the design and development of the trust aspects that we want to include, towards the demonstration and the validation for these developments. I will prompt you, of course, to follow us on the social media and to visit also the website of Assured in order to acquire more information, technical information about our developments. Thank you very much.
Thank you very much, Dimitris, for this presentation, and the latest achievement of this Assured project looks very interesting, actually. And maybe we can also dive a bit deeper in the discussion after the last presentation that we will now have. So the next presentation is about the IoT-SE project that will be held by my colleague Sascha Hacker. He is research associate at the Fraunhofer Institute for Open Communication Systems in Berlin, in Germany. Is involved in various validation and testing projects, and has also experience as an editor in standardization activities at the ETSI. The IoT-SE project introduces multiple innovations to the IoT reference architecture, and we are also developing a new security validation methodology and a certification approach that Sascha will now present. Sascha, the stage is yours.
Yeah, thank you, Martin, and thank you for letting me represent the IoT-SE project here. I hope you can see the starting slide and hear me clearly.
Yes, we can.
Okay, perfect. So yeah, thank you for the introduction. So I would like to present the IoT-SE project, and afterwards I give you some more details of one of our work packages concerning validation, security validation, and concerning certification. So yeah, we are currently in the project in month 12 of 36, and the project consists of 13 partners from different companies and academic and research institutes, and our goal, or our main focus, is on the IoTech framework based on IoTech architecture. So we are going through the whole life cycle of a component or module. So we define and implement methodologies, processes, and technologies, starting with a security baseline that you can see at the right top there, going to security by design methodologies that goes into the SSD platform, the software secure development platform, and all of the results will be automatically tested, deployed, and landing at the end at a validation for each component. So we implement all the IoTech components in a secure way, and all the modules will be based on a secure gateway. At the next slide, you can see all the modules that I've mentioned slightly. So here in the middle, you can see we have an access control module, we have a honeypot module, checkpointing, an attack detection module, and a runtime monitoring module. And as I said, they all will be integrated into a secure IoT gateway. And left on the right side, you can see our, let's say, integration points. Internally, of course, we define some SDKs, and externally we will define APIs to connect to or to integrate the whole architecture or the whole platform. And horizontally, we have the design and certification time. So it's the gray box, it's the SSD platform, and this platform is responsible for providing novel solutions for monitoring and optimizing throughout the whole life cycle, as I said, so from the beginning to the end. And so during the project, of course, as I said, the modules will also be implemented as one reference, let's say, and afterwards they will be validated, and we will also put them into a kind of close to real life demonstrations with various IoT use cases. And such pilots or use cases you can see here. As you see, the domains are different and vary between all the 4 demos, from industry to consumer, automotive, and a drone pilot is also involved with that. So this is actually a rough idea in some minutes, hopefully clearly explained of the project. And now I would like to come to the security validation. As I said, in the short time of a 3-year project, we're not able, of course, to apply a full cybersecurity certification. So what we have decided within the project to have a, let's say, to say whether the modules are secure or not, is to create the validation process. And this validation process is, of course, based on all the activities that we have heard today, and it is nothing that will be something completely different. So we are really aligning with all standards and SDO activities and committee activities that were presented today. So if you can see here, I also brought the tasks and work packages with you, just to show you that this is something that will also go horizontal through the project. And of course, we aligned, as I said, with the ENISA activities, and the assumption that we made for such a security validation was, of course, aligning with all the information we get from other activities concerning certification, but that we are not doing a certification, of course, but a validation within the project. And next to validating the modules, another goal from us is to learn from such a, let's say, lightweight security validation process and bring them to all the activities that are going on a European level. So this is one assumption, and another assumption. Of course, we wanted to create a lightweight process, and this is connected with the third assumption. So we want to reuse almost all project results. So every result or every deliverable that is coming from the project, from the work packages within the projects, will be used as input for this security validation process. And of course, at the end, in the exploitation phase of the project, so after the project finished, we hope that we have prepared the component provider, the component developers, to achieve a real certification that will be hopefully be available. And that's why we are really sticking close to what is happening at the moment at the European level, so that the component developers don't need to start again after the project ends and after the security validation process ends. So the base for our process in general is the EN 17640. So it's the fixed time cybersecurity evaluation methodology for ICT products. And this is currently in a draft state, but we found that it's a very great opportunity to create such a lightweight process. And just to give you an idea on what it looked like, of course not in detail, but this is actually what we are doing here. So we have three different parties involved: the manufacturer or the component developer who wants to get the validation. We have an evaluation facility, and we have a certification authority, or validation authority might be a better wording here in this context. So those zero process components or parties are created within the project. So we are actually doing this at the moment and try to have some idea about the quality and of course the security of the components that are created within the project. And last but not least, a second phase is the certification. This is not a security certification, as we have heard it today several times, but this is how as a third party manufacturer or component provider would use the IoTech platform based on the IoTech architecture. So here we have a little different view. Currently, we are in the phase of creating such an IoTech certification program. So we are right at the beginning here, but we already collected the ideas and the way we would like to go. As you can see at the bottom right, the green box, we have two cases actually for such a certification during the exploitation phase of the project. We call it IoTech conformance certification. So if a third-party manufacturer would like to certificate its component based on the IoTech platform or architecture, that this would be covered by the IoTech conformance certification, and of course the IoTech integration certification. That would be the case if an IoTech module will be integrated into an application of a third-party component provider. So this is actually, of course, the components will also be certificated concerning security, but this certification program is more related to using the secure platform that we are creating within the project. So we are more or less focusing more on the integration part, because I think this would be the more interesting part. And again, we are always based on the activities that are going on during the European level. So we were really looking every day what is new, and will use it as input for our solutions, so that we are not doing something that goes in the wrong direction, and to be aligned with all the activities. Okay, thank you for your attention. That's actually all from my side. If you're more interested in the project, please follow us on the social media platforms, and drop us an email, let us know. And thank you for your attention again.
Thank you, Sasha, for this interesting presentation about the IoT project and the certification related activities there. Okay, so we are now at the end of the presentations of the second session. And as for the first session, we will now start the panel discussion. So I would like to that all presenters are coming now back to this meeting and activate their cameras and microphones, so that we can start discussing questions from the audience. If there are questions that you have right now, don't hesitate to ask them using the Q&A button or the chat of the Zoom webinar tool. And of course, you're also free to ask questions to the other presenters. So do not feel to only answer questions, but you can also raise questions. Okay, so thanks again for having these very interesting presentations of all the ongoing activities that will bring us surely forward regarding the cybersecurity in the IoT. And I have noted some questions during the presentations, so that I will start with, unless you have a question you would like to initiate the panel discussion with. Unfortunately, we don't have each presenter right now in the panel discussion because one had to leave already, but I hope that with the others we can also continue this panel discussion. And my first question would be related to the Concordia project that was presented by Aguro. So I would like to ask you how you see the issues that are identified by Claudio regarding the user perspective are taken into the account.
Sorry, I dropped my headphones and I heard almost everything, but not exactly. So yeah, how do we?
No problem. I will repeat my question. So the question was how the issues that were identified by Claudio in the first session that are addressing the user perspective are taken into account in the current roadmap.
Actually, to tell you the truth, there is no very specific point within the roadmap regarding the user perspective, especially for the IoT devices. It's a little bit more higher up as activities. We pinpoint that there need to be specific standards and specific certification activities and models and methodologies, but it's not exactly pinpointed like that. And I will definitely, since as I said, we are going to issue the last version of the roadmap until the end of the year, I'm definitely going to review the presentation and try to incorporate at least an activity related to the subject.
Okay, thank you very much. So I think that Ruth, you are also still here. Great. So so I have a question regarding your presentation regarding the time frame of standards and technology. So because usually new technologies are developing very fast, and the question is how do you see that standards can be developed fast enough for addressing the issues and cybersecurity issues of new technologies? I think this is some kind of race where standards often fall behind.
Is this for me or for somebody else?
For Ruth was this question.
Ah, okay.
Ruth, can you hear me? It does not seem to be the case.
I could not hear you, sorry.
Okay, can you hear me now?
Can you repeat?
Okay.
Yes.
Yeah, you can hear me now? Okay. Great.
Yes.
So the question is related to the development time of technologies and standards. And usually technologies are much faster developed than standards. And so the question is, how do you see this race between new technologies and cybersecurity issues and standards that try to address these?
I mean, of course, there are different life cycles. So what we are doing is actually is exactly trying to help there to understand right now with the current generation of projects in ICT 56 is to understand where are these projects targeting to contribute, because the contributions are not yet here, right? So they will actually be here in 2023 to 24. And to alert, to assist in creating a set of recommendations from a research perspective on where we should also be targeting. So that is more the direction. And so there is definitely always a gap, but this is something that the only way to address this gap is actually to have a set of recommendations so that direct what to do in terms of standardization. And have a better interconnection between risk and standardization.
Yeah, that sounds very good, and to address these gaps. Thank you. Yeah, another question related to the Fishy project on Enrique. So you mentioned that continuous certification is for SMEs very important. So maybe can you elaborate a bit on that? What you mean by this, and why is this only for SMEs relevant?
Yeah. It's something that we felt it was interesting to address, and mainly because of small and medium enterprises, because since they cannot afford typically a full certification, they can, and normally they have some cybersecurity products running. So the question is, can we take these metrics from these already monitoring working tools and make them adjusted to the security objectives that are related to certification? This is the main question, and we found some cases where it is possible to do that. For instance, concerning the performance and mostly for the availability dimension of cybersecurity, it is possible to measure a lot of indicators from the technology and from the production lines, where we can control somehow and make explicit the availability of the system. In terms of security, this means, for instance, if you have a security objective, having the nodes in the supply chain running in 99% of the time it is available, you can take some metrics to make it continuously. Of course, in a certification scheme, there are many more objectives that are not prone of a continuous assessment, and they are just provided as an evidence. For instance, do you have a risk assessment in place? Of course, you may say, okay, yes or no, and there are no question of doing a continuous assessment of this kind of dimension. But there are a lot of dimensions we found, especially, as I said, in small companies, that we can take and show as real-time indicators of some security objectives being compliant. So, being compliant. So this is what we mean by continuous assurance and continuous certification. Not complete certification, but the part of the certification that should be and must be monitored in real time.
Okay, thanks very much. I think a logical question would be how this could be standardized. I think continuous certification is currently not addressed in the different certification schemes and ambitions for standardization.
Yeah. Do you want me to elaborate a little more about that?
If you have an answer for that, then it would be nice to hear that.
No. Okay, it is a work in progress, of course. And what we are doing, we are looking for the attack techniques linked with the main threads that these small companies, and because the focus are these small companies, so we are helping them to find the main threats, and using some reference documents, we can identify the main attack techniques that are behind these threats, and we are trying to link these attacks with these attack techniques with the effects they produce, and from the effects, what we can measure. So the effective metrics that we can get to measure these attacks. So this is what we are going to present in the next phase of the project, and we are now working on this, and we believe that we can close this gap, and we'll talk and we'll present a list of metrics that can be useful for representing a clear link with the threats that we are facing. So, but of course, this is the main issue we are facing, the main challenge. But I don't know if one interesting contribution. CAPEC is a database of attacks, and they published recently, well, I wouldn't say an improvement, but another form of presenting the data concerning attacks, which can help to find this relation. We are looking for this relation. We are looking for what we call reference document for linking all the phases that we need to address well, the final phase of the risk assessment, if you want. So being able to effectively measure how a security objective is being attained.
Mm-hmm.
And the last, just let me in 5 seconds, the last challenge we have is moving from the technological area where we are now focused to the operational area, the operational technology, because operational technology, as far as you can see, is different, because they don't provide so many monitoring variables. So the indicator from the operational technology is limited compared to the IT area.
Okay, thank you very much for this elaboration. So the next question would be also related to the topic of risk assessment, and I would like to ask this question to Sarah. So it seems that for me that the tolerance metric that you use are an important aspect for the overall assessment of the system, and you have these tolerance metrics that you are using to see whether a risk is acceptable or not. That is my impression. So maybe please correct me if I understood something wrong. And the question to me is, who determines what is an acceptable risk and when is a risk not acceptable anymore?
Yeah, well, in this case, we don't address the creation of this profile. This is just a suggestion of how to measure if a risk is tolerable or not. But for sure, this should be a collaborative work. Indeed, we take the term profile from common criteria. So we expect some similar process like in the collaborative protection profiles, a joint agreement between all the stakeholders involved, policymakers, regulation entities, standardization bodies, manufacturers, to create this measure of what is tolerable or what is not tolerable in this particular context.
Mm-hmm. Okay, thank you very much. So another question is related to how you integrate risk assessment and security testing. So I understood from the presentation that you have this way from risk to security tests. Do you also have the way back to bring the results from security testing back to the risk assessment?
Yeah, the idea is that we use the test results to estimate the risk, in this case, the likelihood. And we also can use the risk assessment when we identify which are the tests that we are going to evaluate over the system, which are the claims. We can also prioritize based on their impact, which are the most important, because certainly we know that it's impossible to test everything in a system if we want to finish one day. So at the end, you have to decide, you have to take decisions. And we think that this prioritization, this initial prioritization can help to elaborate this test.
Mm-hmm. Okay, thank you. So a question to Dimitris regarding the Assured project. And you said in the presentation that the risk assessment process is near real time. So I understand this in a way that there's some kind of automation to perform this risk assessment process. Can you explain a bit about what you are doing there?
Indeed, it aims to provide a near real-time process. So the idea is that by capitalizing on all these attestation mechanisms that we have, we are able actually to acquire information about the state of devices and generally the assets that participating in topologies in near real time again. So all these kind of evidences that may prove that something have been tampered or changed on the correct behavior or the correct configuration of devices are fed into the risk assessment process and are the evidences on tuning and calculating the risk levels of each asset. In this way, and based on the the quantification formulas of the risk assessment that have been defined in ASSURT, we are able to have any real-time indication about the security state of topology of supply chain and so on.
Mm-hmm. Okay, thank you very much. So maybe one question to Sasha regarding the IoT AC project. So you presented the approach of security validation because of the lack of a common IoT security certification scheme. So are there any plans to contribute and to provide the feedback from the project and the experience to the ENISA that is developing this new scheme in the future?
Yes, of course. So we are not just taking ideas from other activities on the European level. We also want to give. That's the idea of having such a lightweight process within the project. Of course, we are time constrained with EU projects, but we also want to give feedback what we have learned. So for ENISA, there are different ways. Actually, some partners from us are part of the SSCG, so the stakeholder groups. So we might go this way, but there are also ad hoc groups that were asked for feedback if such certification schemes are coming up, and we are really waiting to subscribe for such groups and to bring our expert knowledge that we already have, but that we will already learn, or that we will learn during our project with the validation process, of course. Yeah. Okay,
thank you for the clarification. Let's see how this is be addressed by this future scheme for security of IoT devices. Okay. I currently see no further questions. I don't know whether you have questions to the other presenters you would like to raise. If this is not the case, I think we are much beyond the original schedule of the event. So that's actually very nice, but of course also time consuming and may imply difficulties for the calendars of the attendees. But if there's no further question from your side, maybe we can then just close this panel discussion. And I would like to thank all of you for this very interesting presentations, these great projects you are doing, and would also like to thank you for answering these questions in the panel discussion, and hope that we will hear from you, of course, in the future, because I think collaboration is quite important, and you are all working on these complementary topics where we can all benefit from each other, and it would be a great opportunity for all of us. So that from my side, I think we are also at the end of the entire event. I don't know whether Andras would like to say a few closing words.
My only closing words are that thank you for the panelists to be here with us and sharing their insight and information, project information with us. And also I would like to thank to the participants that they were listening to our presentations. And with this, I would just like to close this roundtable. Thank you, everyone. Thanks a lot.
Thank you. Have a nice weekend. And also thank you to Andras and Anna, who organized this entire event so successfully. It was really great.
Thank you.
Thank you.
Thank you very much.